What's happening, everybody? Welcome back. Pastic here again, and today we are going to talk about section 3.6, and we are going to have an objective of being able to model and solve real-world problems using equations. Now, I better not have lost half of y'all just by saying real-world problems, okay? They're challenging, but we like a challenge, and we can do this. All right, so the width of a rectangle is 3 inches less than its length. 3 inches less than its length. And the perimeter of a rectangle is 26 inches. So, first thing I'm going to do is gather some information. And I'm noticing that the width of the rectangle is 3 inches less than its length. So I'm going to write that. Width, 3 inches less than length. I'm going to try and come up with some variables. So I'm going to go over here and I'm going to say W equals width and L equals length. And I'm going to try and write that into a sentence. So the width is, so W equals 3 inches less than the length. So the length minus 3. Cool. That might be helpful. Let's find out. I'm not sure just yet. So what I want to do is just draw a random rectangle. And it's not going to be perfectly to scale compared to the answers. We don't know what the answers are yet. So I'm going to label these two things width and length. And I'm going to see, what do I know as a fact? Well, I know the perimeter is 26 inches. So if I add up all four sides, L plus W, I'm going to have the perimeter, which is 26. So if I add L plus L, that's 2L, plus W is 2W, and that's going to equal 26. That's basically a formula for perimeter. Cool. Well, now I notice I've got an equation, but in the equation I've got two different variables. I've got L and I've got W, and that's no good. I can't solve an equation with two variables. So I got to figure out a way to get rid of either L or W. Well, I notice up here I've got W equals L minus 3. That's actually what W equals. So if I think about this, I don't need this W here. If I really wanted to, I could get rid of that W and make it equal L minus 3. This is a technique that's called substitution. And it's a pretty high level technique, and you guys are going to be able to do it after today. So I'm going to try and set this up so I've got 2L plus 2W. But instead of W, I'm going to put parentheses. And I want to replace W. I want to replace it with what it equals. And we just said 1 moment ago that W is literally equal to, it is the same as, L minus 3. So L minus 3 is going to go there instead of W. And then I'm going to finish the equation. Well, now you got to think to yourself, I've got nothing but L left as the variable, which is good. So I can solve this. So we got to remember how to combine like terms, simplify, all that junk. So what we need to do here is distribute the 2. So we're going to have 2L plus 2L minus 6 equals 26. It's starting to look like an equation that we've solved before. Looked a little tough at first, getting a little bit better as we go here. We can combine like terms. 4L minus 6 equals 26. We now know how to do this, I hope. This is something we've been doing for a while now, but if you don't, it's okay. What's not okay is keeping that problem and not trying to fix it. So if you need help solving this equation at this point, got to talk to me. We got to get together, all right? So at this point, we're going to plus 6. That'll get the 4L by itself. I'm going to come over here. 4L equals, what's that, 32? So that's going to give us L as equal to 8. So if I know L is 8, we can kind of put those 8s here. Whoa, 8. 8, that gives us a total of 16. Well, let's see. That means that W equals L minus 3, which should be, according to what we just found, 8 minus 3, which is 5. That should be W. So 5 here and 5 here. Quick check. Does all this add up? 5 and 5 is 10. 8 and 8 is 16. 10 plus 16 is indeed the perimeter, which is 26. And the question was, what is the width of the rectangle? The width is 5 inches. And that's our final answer. So not an easy problem when you first tackle it, but if you take your time and set it up and keep your calm, you're going to be all right. All right, so now we have the sum of 3 consecutive integers is 72. We want to find these integers. So you got to remember what integers are. Integers are those numbers that are basically counting numbers, like whole numbers, 0, 1, 2, 3, 4, 5. And then the integers also include the negatives. So -1, -2, -3, -4, and so on. And you got to remember that integers do not include decimals. They do not include fractions. So 3 consecutive integers is 72. Well, how do I get from one integer to another? How do I get from 4 to 5? How do I get from 5 to 6? You got to add 1 each time. So what I need to do here is kind of a neat little setup. I'm going to say x equals lowest number of the 3. We got to find 3 consecutive. So I'll say if x is the lowest one, what's the next one? Well, how do I get from 4 to 5? I add 1. How do I get from x to the next number? I add 1. So then I'm going to say it like this, x plus 1 equals middle number. And then how do I get to the next number? That would be x plus 2 to get to the final one. And we'll call that the highest number. So those are my 3 integers, and I have to say the sum of them is 72. Well, how do I do that? I want to write that out. X plus 1 plus x plus 2 equals 72. I've set it up now so that the sum of those 3 consecutive integers is 72. Remember, this is the lowest integer, the middle integer, and the highest integer. So now I just combine like terms and solve like we always do. So I have x plus x plus x. Oops. So 3x, and then I've got 1 plus 2, so plus 3, equals 72. I'm going to solve that by subtracting 3, 3x equals 69, divide by 3, divide by 3, x equals 23. That should be the lowest number, making the middle number 24, making the final number 25. And I can get those values by putting 23 here, here, and here, or I could just use a little bit of logic. And then I want to check to make sure it's right. 23 plus 25 is 48, plus 24 is 72. So we are good to go. All right, so on to the next one, and these are traditionally a little bit more challenging because they're not as obvious when you first read them. So we're going to take our time and set them up, and you're going to want to practice a couple of these. So an airplane left an airport flying at 180 miles an hour. Cool. Pardon me. A jet that flies 330 miles an hour left 1 hour later. All right, that's probably important. The jet follows the same route as the airplane at a different altitude. Wonderful, that means they hopefully won't collide. How many hours later, or how many hours will it take the jet to catch up with the airplane? All right, so kind of a bit of a different question here. Let's start simple. What you gotta know in order to do this problem is you have to know the very foundational formula. That is, distance equals speed times time. How far something goes depends on its speed and it's how long it's going that speed for. So if I go 50 miles an hour, I can go 100 miles in 2 hours. 50 plus 50, or 50 times 2. So we're going to need to use this foundational formula, which is distance equals speed times time. We're going to need to do it for both airplane and jet. So, airplane, do we know how far it goes? No. So we're going to say distance equals. Do we know the speed of the airplane? Yes. It's 180 miles an hour. Do we know how long the airplane is flying for? No. So we're just going to call that T. So over here I'm going to make a little note. T equals how long airplane flies for. And then we got to do the same thing for the jet. So this is for the airplane. Hopefully I'm spelling airplane right. Yeah, I think I am. All right, so now we're going to do the same thing for the jet. So over here, we're going to go D. Do we know the distance for the jet? No. Do we know the speed for the jet? 330 miles 330 miles an hour. But we know the jet left 1 hour later. So if the jet left 1 hour later, that means it's going to be traveling 1 hour less than the airplane, because the airplane has already been traveling for 1 hour when the jet finally takes off. So the jet is going to travel for T minus 1 hours. Wonderful. And again, that's just because of how I set it up. You could have set it up so that the plane was traveling for T plus 1 hours and the jet was traveling for T hours. It's just a matter of what makes the most sense to you. So now what do we know? We want to know how many hours will it take the jet to catch up with the airplane. If they catch up to each other and they left from the same spot, that means their distances are the same. That means that this distance has got to equal this distance. So let's set that up. We're going to go 180t equals 330 parentheses t minus 1. And now we need to solve that. So in order to solve that and save some time on this video, I'm going to go through the steps and then I'll be back. So at this point I've solved it, and the reason I did that is because this video is getting a little long and I don't want to have you guys have to watch the whole thing, but you should know how to do this at this point. But again, if you don't, that's okay. Let's just chat about it. Let's figure it out together. So again, first step here to solving, I distribute. Once I distribute, I'll kind of highlight a little bit. Once I distribute, I notice that the t's were on different sides. We had a 330t here and a 180t here. So I subtracted the 330t to get it on the same side as the other one. And from there, it's business as usual, dividing to find out that it takes 2.2 hours for those planes to meet. All right, so on to the next one. So this one's kind of a similar problem. It says, suppose you hike up a hill at 4 kilometers per hour. That's giving you a speed again. You hike back down at 6 kilometers per hour. Again, a speed. Your hiking trip took 3 hours. Okay, so this time they tell you the total time it took. How long was your trip up the hill? So what we've got again is two distances that are equal, because your trip up the hill should be the same distance as your trip down the hill, unless you took a different route. But if you took a different route, that's going to change everything, right? So we're going to assume that our distances are the same, and we know the total distance is 3 hours. So let's start to set this up. In order to set it up, I'm going to set up two situations again. I'm going to set up the hill, and then that's hill, I don't know why. And then I'm going to set up down the hill. Much better. All right, so up the hill, what do we know? We know that there's some distance that we don't know, d. We know that they're going 4 kilometers per hour. That's their speed. And again, we're using distance equals speed times time. So 4 times their time. We don't know how much time it took them to go up the hill, so I'm going to use t. What about down the hill? Down the hill, same idea. A little bit of a tricky piece to it though. Distance, we don't know, so we'll call it d. Speed, we do know, is 6. Time, we don't know, but we do have an idea. We know that the whole thing was 3 hours, right? So a little bit of logic tells me that if it took 2 hours to go up the hill, then it took 1 hour to go down the hill. So 3 minus 2. If it took 1 hour to go up the hill, then it took 2 hours to go down the hill. 3 minus 1 is 2, right? So if we know it took t hours up the hill, and we know that it takes 3 minus t hours to go down the hill. So this one is a little bit different. So the time it took to go down the hill is 3 minus t. How did I get that? Well, that's the total time, 3, minus however long it took to go up the hill, which is t. What do I know now? I know the two distances are the same. So again, I'm going to set this equation up by putting the two parts together. I've got 4t. That's how far it takes to go uphill. That's our distance, right? We know that's got to be equal to this other one coming down the hill, which is 6 parentheses 3 minus t. So we can now solve this. And again, I'm going to pause the video because we're getting long. I'm going to finish solving it and I'll talk to you. So as you can see, I've solved the problem in blue here. My first step was to distribute 6 times 3, 18. 6 times negative t is negative 6t. And then I noticed again my variables were on different sides, so I moved the 6t over, so plus 6t to both sides, giving me 10t equals 18. Business as usual, divide by 10, we get t equals 1.8. And I apologize for not doing that all out, y'all, but it's taking me too long to make this video. And I apologize for the length of the video, but so it goes. So t equals 1.8. The question is, how long was your trip down the hill? Well, we just said this is up the hill. We just found how long it took to go up the hill, 1.8 hours. How do we find out how long it takes to go down the hill? We said over here, it would be 3 minus whatever we found for t. So down the hill is 3 minus 1.8, which is 1.2 hours down the hill. A little bit of logic tells me we did okay because it should be quicker coming back down in theory. So last problem, people, and another tricky one that tends to be a tricky one in the past. We're going to try and do our best to break it down piece by piece and give you some experience with these, okay? 2 jets leave Dallas at the same time and fly in opposite directions. All right, so we got 1 jet leaving this way and 1 jet leaving this way. We know that one is flying west 50 miles an hour faster, so we'll call this one the west one. We'll call this one the east one. 50 miles an hour faster than the other. All right, so that tells us something about our speeds. So one is flying west 50, so the fast one is flying west. So we're going to say the west plane is x plus 50 miles per hour. It's going 50 miles an hour faster, okay? And then we're saying the east plane, we're going to say its speed is just x miles per hour. So let's see if that makes sense. It says one is flying west 50 miles per hour faster than the other one. So we said the east one is flying x miles per hour, the west one is flying x plus 50 miles per hour. After 2 hours, they are 2,500 miles apart. Find the speed of each jet. So what we're going to do is set up 2 equations again. What's the distance for the one flying west? Well, we don't know. So this west one, we know the distance is what? Speed times time. Do we know the speed of the west plane? It is x plus 50, right? Speed times time. So x plus 50 is our speed over here. And how long is it traveling for? Well, it says right here, 2 hours. So that looks a little backwards, but you can put the 2 in front if you want, and it makes it look a little bit more normal. The next one, the reason I did that was because I'm trying to keep it in the same pattern as distance equals speed times time. So that's what we have here, speed times time. The east plane, we don't know the distance, again, but we do know how fast it's going. It's going x, which we don't actually know, but we're calling it that. And we know it's going for 2 hours. Okay, well I got 2 distance equations. what do I know about them? They're not equal. They're not equal this time because they're going different speeds, but I do know that they add up to 2,500 miles because that's how far apart they are. Like if they both start here, one goes this way and one goes that way, and their total distance apart is 2,500 miles, then we know that the two total distances of each plane add up to 2,500 miles. So let's write that equation. We've got 2x plus 50, that's our westward bound plane, plus 2x, that's our eastward bound plane, equals 2,500 miles. So I'm going to pause it here, solve that out, and then we'll get back together. Okay, so as you can see, I have solved the equation. Again, my first step was to distribute the 2, and I get 2x plus 100 from doing that. Then my next step was to combine those two 2x's to get, so I only have one term with a variable. So I did that here, and I got 4x plus 100. At that point, it's business as usual, subtract 100 from both sides, divide by 4 over here, and you can find out that x equals 600 miles per hour. We called that the east plane, so that one's going 600, and if that one is going 600, then this one over here, the westward bound plane, is going 50 miles per hour faster, so 650 miles per hour west. And we got our two answers. If you wanted to do a quick check, which you should, you could throw the 600 miles per hour right here. 2 times 600 is 1,200, that's good. Over here, 650, 600 right here, plus 50, 650. 650 times 2 would be 1,300. So we have 1,300 miles traveled for the westward plane, 1,200 miles traveled for the eastward plane. Add those up, you get 2,500 miles. That was a lot, y'all, so thanks for sticking with me. I'll catch you next time.